Hi, we're Team Hindenburg, and as requested, we're updating you on our design proposal for the model airship. We'll briefly introduce ourselves and talk about our discipline-specific areas and where we're up to with our design, and talk about the evaluation of our components as well. I'm Travis. I'm a second-year mechanical engineering student.
I'm Jake. I'm an electrical student.
I'm Owen. I'm a second-year mechanical student.
I'm Tom. I'm a mechanical student.
I'm Lindsay. I'm a civil student.
I'm Gil. I'm a second-year electrical student.
At this stage of our education, we've all worked on basically the same projects. We designed a tower last year. We also did an industry project. What else did we do?
Mechanical, electrical. We've had experience across all areas, so we believe we're a capable team.
As you've provided us the project brief, we believe we have kept our design within the specifications that you've provided. We are currently at a stage where we are trying to implement a turning system in the case that we have to run the racing side. With some initial research done, we found some existing designs and took some rough sizings from them and have evaluated a few different sizes of balloon. We've currently decided on a 10-metre long balloon, as we feel it's best to be able to repurpose it after the race to hire out for events to use as advertising.
A gondola would usually refer to a compartment on a blimp capable of safely containing people, but in this circumstance we'll be referring to it as a plastic case containing the batteries, motor and general circuitry of the device. The gondola will hang at the bottom of the blimp and around the centre to prevent one side getting heavier than the other and thus tipping over. The gondola is designed to be plastic due to the load being quite light and the advantage of the gondola itself being light. Its weight has already been assumed, and the cost, choice and justification of the choice of the type of plastic is beyond the scope.
The gases used in the design for the airship, it's basically just helium. It was chosen over hydrogen because of safety purposes. So the design itself will contain approximately 24 cubic meters of helium. As on behalf of the mechanical students, we've basically finished all of the design things, and now we are focusing on the report stages of it and also the Australian standards for transportation of gas, handling gas and other relevant ones to the airships.
Alright, moving on to the electrical aspects of this project, it can be seen that we as the electrical engineers have started to create some basic designs. For instance, we have started to create a system for the airship itself. It consists of a battery, a switch, a radio control unit and the chosen motor. Quickly just going over the parts, the battery is basically just going to work as a power source to give electrical power to the rest of the system. The radio control unit just controls the motors and other aspects of the system which require the user's input. And finally, the motor itself is just a way of controlling the electrical energy and outputting it as kinetic or motion. Right.
After some more research, we developed the circuit design even more. We added an additional motor to allow it to move sidewards, and we've also added an additional motor to help it move forward. This will allow us to increase or decrease the battery size based on what the rest of the circuit is doing. We've also changed the control system to be a 2-channel receiver. This way we can have a control that has 2 throttles and 2 switches for each motor. And for these components of the circuit, we've come up with weighted criteria which we'll use to determine which types of components we're going to use. This includes the reusability, the size, weight, safety and cost. And from this we'll be able to find the values after we determine which types of components we'll be using in the circuit.
Alright, moving on to the design of the system that we've implemented on the tower. It's basically just going to work as a magnetic field to draw in and dock the airship. As of such, it's a very simple design. It just consists of a battery as a power source, an electromagnet or a solenoid to create a magnetic field to pull in the ship, and finally just a switch for emergency measures and just to release the airship after it's done. Okay, looking at what the electricals have done so far, however, it can be seen that we still require to choose our physical components as well as start the reporting stage of our documentation.
Okay, as the only civil student in this team, my job was basically to design the tower. I began my general research with truss designs. From here I chose 4 types of trusses to evaluate. As you can see on the screen, this is my evaluation criteria. From here I've created a weighted evaluation criteria, and as you can see the K truss was chosen to be the best option. From here I need to analyse my design, choose my material and determine my member sizing. From there I will then transition into the report stages. Okay, so as Travis said before, we are Team Hindenburg, and we believe that we are actually up to date and on track with this project. If you have any further questions or queries, you can contact me. I'm the team leader. My email is actually on the screen. So yeah, that's basically it. Thanks for watching.